Hello students. So we have completed our IPv4 protocol concepts, and we have seen how these addresses were allotted, how we can implement subnetting with class 4, classless, and the rest of the things. Now today we will discuss the next version of IP protocol, which is known as IPv6. So first of all, we have to understand why this IPv6 is required. So if we see, as we have discussed at the time of IPv4, that classless addressing was introduced to avoid the wastage in IPv4 addresses. But if we take and see the growth of internet, we will find that apart from the usage and then plus wastage, IPv4 32-bit IPv4 address is fully exhausted, and not a single address is remaining for any client in present scenario. Okay, so the first and the most important thing is the shortage of IPv4 addresses for new networks. And slowly we can see the growth of internet is huge. Mobile applications are taking place of laptops or PCs because smartphones are now much enabled with each and every type of computing facility, right? And one more important thing is there. In recent times, we have heard about the concept of IoT, Internet of Things, in which each and everything of our house, our society, or in short, we can say in our surrounding, will be on networks. So it also requires huge address space. So considering all these issues, we have to find out a new way for the upcoming internet world. So if we see the data analysis of this address space, then you can see the internet population, and that is compared with the world's population, like 630 million users at the end of 2002, which is the 10% of world population, and see the growth after 5 years becomes double, and in future, if we talk in terms of future, means like 2050, let's take an example of 2050, then the requirement will be, world population will be 9 billion, and similarly you can compare the requirement of IP addresses. And one more data is available, like in US uses 92 per 8 second IP address requirement. So nearly 6.4 IPv4 addresses per person is required. So if we see what is available here, we need 7 times larger address space. Okay, so this is why we have to switch to some new address space concept, and obviously we have to improve our operating system, different type of services, applications, and contents as well, so that each and every existing application can run on this new IPv6 address space. Because if we allot IPv6 address to new clients, new organizations, and they will work accordingly, then what will happen with the existing previous millions of IPv4 based networks, devices, routers, application gateways, and everything? So we need to consider all these scenarios before implementing the IPv6. So the challenges are similar. You can see address space, header specification, checksum, hop segmentation, 64-bit aligned. So we have to compare the header format of both these protocols. So you can see the difference between these two. Like IPv4 consists of number of fields and IPv4 header is less number of fields, and color differentiation is also mentioned, that legends are mentioned below the diagram, that you can see which field is new and which one is removed from IPv6. So this is the differentiation between header of these two protocol. Now see the calculation and the availability of address space in IPv6 in comparison with IPv4. Now you can see, we know IPv4 is 32-bit long address. Then IPv6 is defined as 128 bits address. It's huge. And if we see the calculation based on these numbers, then possible addresses can be generated. In IPv4, it's a big figure and already exhausted and no addresses left. Then in 128 bits, which is 4 times of in terms of size of bits, then 3.4 into 10 to the power 38 possible addressable devices, or you can say addresses, can be generated, and this will be a final calculation which we cannot reach. It's huge, it's a very big number, and approximately 5 into 10 to the power 28 addresses per person on the planet we can allot with the help of this IPv6. So why this size is chosen, a lot of discussion were there when then internet community and experts are planning for this IPv6 address space. What will be the size? Somebody says it should be dynamic, some says no, it should be static or fixed. Then finally the settlement was 128 bit, because somebody said 256 can be a good number, but in computers things should be always considered or launched in terms of optimization as well. Data should not be less and data should not be more. It should be balanced. So it should be balanced. So in case of 128-bit addresses, we can fulfill the requirement of users in coming futures for a long time, right? Now, the representation of IP addresses we should know about. In IPv4, we call it as dot decimal notation, but in IPv6 it is separated by colon, and 16-bit field will be there, 16 bits of 8 octets of 8 fields of 16-bit each. So this becomes 128, and fields will be separated by colon, and in IPv4 fields were separated by dot, right? There are few notations are also there. Suppose in above address we can see that few fields are consist only of 0, then we can write it in shorter notation like this, single 0 will be enough. Even one more notation is there, we can use double colon without 0, but in that case successive field should be of 0, right? They should be continuous in sequence. Then we can put double colon like this and without putting 0 here, and you can see the correct and the incorrect address writing pattern, because here single 0 is there, so we can't put double colon, right? Similarly, few more addresses are defined that we can see further. A table is there which can explain each and everything. So these are the notation of IPv6. In at the time of a start, some few more representations are there, like you can see such address can be 0 will be replaced by double colon. As we can see, IPv4 compatibility was there, but it was not successful, so it's removed. Like we can merge the IPv6 and IPv4 addresses as well, or convert it into IPv6, but it was not a successful game, so it was withdrawn by the internet authorities. And in case of URL, a proposal was that complete IPv6 address can be enclosed in square brackets, and then page name should be there, but this will be very cumbersome or difficult for the user to remember IP address. We are very much comfortable with the names. So now the next one is, like we have seen the prefix or subnet masking kind of thing in IPv4. Similarly, we can allot subnet mask or prefix for subnetting and everything in this IPv6 as well in the similar manner. There is no syntactical change in this, right? So again, I will compare it with IPv4. As we have seen in IPv4, address types were there. Then here three address types are also here: unicast, anycast, and multicast. As we know, unicast is one to one, anycast means one to nearest, and multicast means one to many, right? And in case of anycast, you can see allocated from unicast, means you can send to a groups as well. And no broadcast address is there in IPv6. We use multicast for the purpose. Now you can see the complete table of predefined and fixed specified list of addresses. Like all zeros are not defined in this particular IPv6 notation. Hexadecimal notation is also here. Loopback, as we have seen in IPv4, loopback address were 127.0.0.1, but here it's only one and rest fields are blank, or you can say 0 will be presented as loopback address, right? Then global unicast is like this, in hexadecimal like this. Link local unicast address is like this, right? Then unique local unicast address. These are the special purpose addresses which is predefined, and there is no need to change in it, and we can't allot these addresses to any particular client. These are the addresses can be used by ISPs or some other authorities, or maybe if you can use in your network as well. Okay, so this should also be a very important thing which you have to remember. Now if we divide this address space into fields, like in IPv4 we divide the network address, then host ID, etc., and so on. So similarly we can assign, here we have divided different fields in it. First 12 bits are for history, then 32 for prefix, and similarly we can move ahead in this repository. You can see the most important thing which you have to look here is 64-bit for host, means interface ID, means we can allot to the different clients. So 2 to the power 64 host on one network LAN. If we calculate this, you can see the figure, which is huge. And 16-bit address reserved for the end side, means for network address 2 to the power 16. Now you can see how much subnets we can generate in this particular scenario, right? And in IPv4 it was /12. So here we can see the growth of this. Then 16 bits is reserved for each service provider, means ISPs, and earlier it was /8 in IPv4, and 29 bits reserved for all service providers. The bigger service provider means network service providers, that will be 2 to the power 29. So this is the kind of address which is divided into large number of bits, and each and every section of IPv6, or we can say each and every field of IPv6 is large enough to fulfill the requirement of users. So this is all about this lecture. I think it will be good understanding for you for IPv6. Thank you.